All right. So we are doing the encoding of the round data, the opposite of the decoding, which we have figured out by reverse engineering the game. So we ended up, we did the first 3 bytes and then the 4th and the 5th. Now the next stuff we have to do is, so byte 5 contains the data length and the algorithm. We don't know the data length, obviously. So I'm going to push a temporary value here, because this is the data length we have to overwrite this once we encoded the level, right? But we have to have this value reserved, right? We have to have it in position. So let's set the algorithm to horizontal. Yeah, let's do that first. Well, I might as well do the same algorithm where they choose the smallest size, right? So, but we have to start somewhere. So let's do the horizontal one first. That's the easy one. Just go left to right, top to bottom, which is just reversing the array, right? As opposed to going vertical, where you have to go column by column. So yeah, horizontal, that would mean, yeah, so we still, let's do horizontal. So we have to loop the size of blocks. I guess we can do that. Well, it's 11 by 11, right? But we do have, we have blocks dot length. Okay, so we're looping all the blocks. And this is horizontal, right? So top to bottom, left to right, top to bottom. We have to keep track of current block ID, current block. We have to keep track of the current count, because we have to like go to a maximum of 8, and we have to write that stuff to the data, right? Also, let's keep track of the amount of data written. Because that's what we will be putting into this value here. So let's see. So current block at the end of this thing is definitely going to be blocks I, right? And then the question is well, if current count equals 8, we have to write. We have to dump the current value to the data. So that's a condition to dump. Also, if the, actually this should be previous block, and then that current block equals blocks I, right? So if the current count equals 8 or current block not equals previous block, that makes sense, right? That we have to process a different thing there. Then we have to, so we're gonna write something. So yeah, we have to increment that one. And then we just have to encode, right? So we're writing previous block into the array with its count. And then we put current count to 0, right? Because we're starting over. Yeah, so we are starting over the algorithm. So all we have to do now is encode the value, right? So if you go look at the value, what was it? Yeah, it's this here. The repeat count and the block value are separated by the top 3 bits and the bottom 5 bits. So the repeat count is the top 3 bits, which is a maximum of 8, but we have to subtract 1, right? So we will the encoded value equals the current count minus 1, right? Because we're losing the bottom bit because we don't do 0, right? It's always 1 or more. So 0 becomes 1 time, 1 becomes do it 2 times. And then we shove that in the, oh no, it's the bottom 3 bits. Let's start with the block value though. That's easier because we have to shift that to the left simply. So F8, let's double check. F8, if we view that in binary, that's yeah, the top 5 bits, right? So all we have to do is shift that thing 4 bits to the left, or 3 maybe, I don't know. So yeah, 3 times to the left, I guess. So that would be previous block shifted 3 times to the left. And then we just add the current count minus 1, right? Yeah, that would add it to the bottom 3 bits. Yeah, so let's see what that ends up as. And then of course we have to push that. I guess we don't have to put that in a different variable here. And then I guess this is an else we do current count plus plus, right? We have to increment the current count because we have the same block and we're not at the limit yet. Yes, I think that is the case. Okay, so we don't need the encoded value elsewhere, so let's just remove this variable. And okay, so right, so that's the top bit being set. If it is set, it's vertical, so we have to leave it unset for the horizontal algorithm, so we can just assign data length. So data at position 5 was it? Equals data written count. So let's see what that brings. Right, so we have 5 values. That's definitely not enough. Okay, I needed to refresh, of course. So we have 113 bytes. I see a -1 here, though. Well, I mean, that could be the case. I'm not seeing these as hex though. Let us write a thing to download the file perhaps, so we can watch this in a hex editor. Yeah, 1087, that's a bit much, I think. How can that be? Oops, not this one. Yeah, that's not correct yet. Yeah, that's 43F. That's way too much. That's impossible. I do want to try this, see where we go though. So and let's just add some debugging here. Limit reached. Value equals, well, we have previous block. And the count. And then result, well, now we do need it in a variable, of course. 1 second. So now we have it, we need it in a variable, right? I mean, I can just do the same thing. Does that work? Yes. Okay, so where do we start? Limit reached. Previous block is null. Okay, so we have to ignore null though, because that's resulting in -1. The count has to be over 0, right? Yeah, so the first iteration has to be skipped because of our null. Okay, same block detected, that's fine as the first one. And then we reach the limit, yes, because 136 only appears once, that's low. The result is 1088, that's incorrect. So our value is 136, which is 0x88, if I'm not mistaken. And that would result in, let's see, nope, I always keep clicking on this one. So we have to shift 136, which is 0x88, to the left 3 places, which is 1088 though. Like, let's do that in hexadecimal. Yeah, that's not possible. So 0x88. I mean, it's the same value, of course. Hex 440, 1088. Wait, so let me look at the bits here. Okay, so that's, oh no, that's not shifted. Wait a minute. So these values are not shifted, they're just added. I don't need to shift it to the left. I just have to, so the bottom 3 bits are always, or the bottom 2? No, the bottom 3 are always empty for every cell ID here, like this. If we look at the cell IDs, these guys, Yeah, so 8 has the bottom 3 open, 10, 2, yeah. So we just have to, they're already encoded in the top 5 bits. So I do not need to shift at all. So yeah, 6, 8, for example. Yeah, the bottom 3 bits are open. Because I never shift them back to the right, right? Right, that does make sense. I mean, I could have shifted them back to the right, but then you just end up with values that are shifted 3 bits to the right, but that makes no sense. Like that doesn't really matter. I don't know if the game does that, but that's actually irrelevant. We can just ignore that. So yeah, we do not need to shift to the left here. So we're just adding, I guess. Which makes sense, I guess. Yeah, so we don't have our 1088 anymore. Yeah, so it stays 136. That does make sense because there's only one and we're starting from 0, right? So 0 means 1. Okay, so then the next we have to do 2 times. So we have 2 walkable spaces here, horizontally. A walkable space is 8, I think. Yeah, that's 8. So we have 8, but we have to add a count of 2, which becomes 1. And we're not seeing that. That's not being added. So unless... Also, this is previous block is 0 is also incorrect, though. That's impossible. What am I doing wrong here? So let's... Okay, we have current count is 1, so it's not... Yeah, it's this inequality that is triggering. It's detecting a different block, right? Actually, we have to reset current block here as well, I think. Or previous block, I mean. I think so. Because we don't want to go on. It doesn't matter. Once we write a byte, it does not matter what we're encountering in the next block, right? So we have to reset that. I think that's better. Okay, so we are pushing 136. Yeah, and now we have count of 1. But why would it be... Yeah, it's doing the same mistake though. Oh wait, I think this one is messing with incrementing my current count here. Yeah. So what do we have to do specifically if previous block is null? That means we're either starting or we just wrote a byte to our data. Then we just have to increase current count, right? Yeah, that does make sense though. That's all we have to do because wait, we are doing this and then this though. That's not good. To wait. So in the case that the current block and the previous block are the same, this doesn't get executed, this does. And then we're overwriting, but they're the same, so it doesn't matter. Then if they are not the same, then this triggers. We are writing out the block. Okay. So we are in a situation where we are encountering a different block. Okay, that's fine. So we are writing the previous block out, right? The previous block with its current count, which that hasn't been reset yet. We're incrementing the data written count, fine. And then our current count is reset and our previous block is set wait. This has to be the current block though, which we're doing anyway. So this is irrelevant, right? Because we're doing this anyway. We have to put it to the walkable space here. So we can't do that. Okay, setting the previous block to current block. Oh no, not this. So we're starting with same block detected. Yeah, of course. Yeah, that's because, well, I mean, it's not same block detected, right? It's also if the previous block is null, but that's fine. So we're setting the previous block to 136. The limit has been reached because the current block differs for a count of 1. Okay, setting previous block to 8, which is walkable space. And then same block detected, incrementing current count. Would that not... Oh, should this be 1? I think that might need to be 1 though. Because, yeah, we're handling the current block, not the previous block, right? Which is always 1 then. Right, setting previous block to 8, same block detected again to 8. Yeah, now we have 8 and 2, which becomes 9. And that's correct, right? We have 8 as the block value and 2 becomes 1 because we subtract 1 and we add both together and that's 9. So we have the 2 spaces, then we setting previous block to 0. Oh, that's wall, I think. Yeah, so we have wall for 1 resulting in 0. Is that correct? If we have completely 0, like wall is actually 0. That we're talking about this wall here. That is actually 0. That makes sense. Yeah, 0 for a count of 1 is 0, right? That, well, we'll see with these 3 walls now. So then we have 8 for 1 time becomes 8. 0 for 2, yeah, or 3 blocks becomes 2. Yeah, because the value is 0 and the count becomes 2 from 3 to 2. Yeah. So I think this seems to be working though. What 4 do we have here? Wait, where is our 4? I don't see 4 consecutive blocks though. Previous block is 8. 8 meaning walkable space. Oh, it's 1, 2, 3, 4. I think that works. Yeah, that works. That should do the trick. Yeah, that's these 4 spaces here. That becomes 11. Yeah. I don't think we have any wrong values anymore. Let's look at the array of data. Okay, so I do not know by heart which algorithm was used for this first level. So we're going to take a look at that. So this is round 1, the 3 power-ups, the loader position, exit position, and an exit position and the data length, and then so A5. Let's see if the top bit is set in A5. It is. So it's using a different algorithm for the first. It's using the vertical algorithm for the first level instead of the horizontal one. So we can't like compare exactly, but what we can do is try to load these horizontal bytes into a file and see whether it actually loads the data. That would be interesting to test by my own algorithm, of course, but yeah, that doesn't really matter. Now I have to look this up because I do not know, or HTML5, yeah, it was an invisible iframe or something like that, right? That string, and I do need to. This fetches something. I don't need that. I need download array as file. Yeah, that's not what I want. I think. Well, maybe I can do base 64. Okay, so they're converting it to a uint8 array. Create object URL. Oh, right, that's one of those data things, I guess. What does this exactly create? I guess that's opaque, perhaps. Okay, we have to revoke that as well, I guess. So why do they go to base 64? So blob needs array buffers. Okay, but why are we converting to a base 64 version of this PDF here? Wait, is this deconversion? I always forget which one is which. A to B decodes a string of the. Okay, so yeah, it expects bytes here, so we don't have to do that because we already have bytes. Also, it converts it to ASCII though. Why are we doing that again? Returns an integer between 0 and 65k. Sure. I'm just going to try to do this with my data straight though. Well, new blob for array of bytes here. Yeah, because this, well, maybe I need to convert to a uint8 array. I guess I can do that, right? Does this take a thing for a simple array? Type the array from. right, I can do this perhaps. Can I? Does this work? Apparently it does. Okay. 106 is my length here. Let's see if that is correct. Well, 106 becomes 112. So yeah, we have 6 bytes at the header plus 106 bytes length here, so that is indeed correct. So yeah, we have a uint 8 byte array, or a uint 8 array, which we can just feed to a blob, right? We have a blob with this. Why would it put that in an array though? And that MIME type is, what was it again? Forgot. Octet, the octet stream MIME type, what was that again? Is it application octet stream, or yeah, it's application, I think. Yeah. And right, let's just put that link thing in the HTML, so we don't have to create that every time. And we don't have an href. Okay. Wait, what did I do? I need an A, not a link. And the file name is report. That's fine. Oh, .download they use. I didn't know that. Okay, that's fine. Let's give it an ID is download link. Let's see if we can call this now. So what are we setting? The href equals window.url.createObject URL of the blob, and then link.download. I don't know that attribute, but sure. PZL for puzzle, and then link.click. Does that work? Yeah. Let's see. Yes, it does. That's interesting. Okay, we have our test puzzle here. It's missing the header though. Like, I'm not worried about that yet. So we have test puzzle, which is completely wrong. So we have to, yeah. So 30. Those are the. This is 1 1 or 0 0 0 0. But then right. So we don't need the char code at, I guess. What is this dumb system? So if you go look in the ASCII table, 30 is 0, right? I think I'm not mistaken. 30 decimal is, no, 30 hex then, which is this one. Yeah, that's 0. So 30 hex is 0. So it's, instead of putting a 0, it's putting the hex value here. So we do need charcode add. That's weird. Like, why? Also, they could have made it more visible that this address is separated from the data though? Like, why would you do it so close together in this hex editor? Yeah, so we do need to manipulate this with this charcode add thing though. Yeah, so let's do this. Well, let's just copy it into an event 8 array then, because this stuff does the wrong thing. Let's call that blob data. So let's allocate a new array, and we also have the length now, right? That would be data written count plus 6. 6 being the header size. So that's the amount of data we have to write, and then we just loop I guess it's everything, right? Data written count plus 6. And then we will put in blob data position I the data dot. That's weird though, because that's just is that gonna work? I'm not sure about that. Yeah, that doesn't work. Well, yeah, charcode add is for a string, right? Yeah, that's for a string. That's not for an array. So why would it not copy these values exactly though? Like, what is this bullshit? Like, that should simply work though. Okay, so let me see both of them next to each other. That's weird. Refresh, export. So we have yeah, so these values are the same though. Like, why would they be written incorrectly? Let me open this in a thing though. No, not destination here. I want a terminal here, so I can just exam that dash C. That's easier than opening the thing every time. Tests. Oh, it's just a brace. Okay, why? Yeah, that's still wrong though. Like, why is this? Oh, was there something? Oh yeah, I did this elsewhere too. Was it in the encode or the decoding? Yeah, so I do have a charcode add here too though, like, and it was charcode add. So here I am doing pretty much the same thing, right? So I'm doing an A to B, which is a decode of the data. So this becomes a string then. Does window ATOB return a string? Yeah, of course. So that's why charcode add works here. So, I mean, I guess I can do if I convert data to a string, can I do that? Listen, these websites that usurp the search thing, I hate these things though. MDN array to string without typos. Okay, so that does work. A string representing the specified array and its elements. And it had better not touch those things though. Touch those values. So if we now do this data, well, let's only do it once, of course. Data string, and then the function call was charcode add, I think. Yeah, charcode add I. Okay, so now let's see if it's different. Like, no, now they are, well, Well, I guess. Let's look at the values on disk here. Nope. Nope. Why is this so difficult? That's so stupid. I mean, I have an array of bytes, and I just want to fucking write the array of bytes to a file. Like, how hard is that? Like, so annoying, JavaScript. And I mean, this doesn't have to be an array, right? Why was it an array here? I don't remember why, but yeah, no, that's the same shit. Right, now you get this nonsense. Like, incredible the amount of stuff you have to do to get a simple integer as an 8-bit value written into a file. And I'm actually doing what they're doing here, right? So we're looping all over the data. ASCII is binary string, charcode add I. That's the same thing, right? Do I need the inverse, perhaps? So it returns an integer between 0 and 65k of the string value, but yeah, of course, I'm doing two strings, so why I already have the bytes. Right, so with base 64 decoding, I guess you get a as a string, and you want the numeric value of a, like let's say 65 or whatever the lowercase a is. But I don't need that, right? I do not need to convert it to a string because it's already data. It's already an array of bytes. So why would this not work though? I don't need to do this. Like I already have an array of numeric values. Like if I want to convert it, like this is the exact same, except for the charcode add is exactly the same as saying blob data equals uint8 array from data, right? So for whatever reason, if it needs to be a specific type, being uint8 array, like a typed array, sure. But then that's what I'm giving you. Like it's literally the exact same thing. Question is why is this garbage? Like, well, yeah, sure, I don't want the data spread out or like as an array. But why would you do it like that? Why would you convert it to a string? Because we have 3 zeros, then the fourth zero, and then 133, but it's converting the number to a string. Part is an array of data objects. Okay, so the fix not easy to discover because oneself are seeing one and another time. What is this? Is to use brackets to create on the fly an array of elements. Okay, they're doing the same thing though, but why? Like, that doesn't make sense to me. Okay, let's use blob data then. Now we're doing it on the typed array, right? Okay, so what does this give me? Incredible. That's what we need, right? 85, 6A, 88 is the first Lolo, then 8. 1 times 8, which is 2 walkable spaces. Then 0, 0 is 1 wall. Right, and then right. Okay, so that's how it works. Okay. Dumb shit. Can I put this in here? So we hide that stupid stuff. Yes, we can. Okay, so we have our bytes. Now I want to test this out in my test application here, like in the C++ application, to see if this is decodable, right? I can already see why they chose a different algorithm. It makes sense. This is more of a vertical level. Like if you look at run length encoding, it's like the entropy or something like that would be bigger if you go horizontal and smaller if you go vertical, right? Yeah, that does make sense. Because you can, over here you can say, okay, give me 10 white spaces and then like 8 walls and stuff instead of doing 0, 1, or 1, 1, 1, 1, 1. That's way more or way bigger than if you do it vertically. But that shouldn't matter. Like the algorithm should do exactly what you give it, which is a horizontal version of this one now. So okay, so I'm gonna download it again. So I have only one test puzzle, and this is our data. Okay. Oops. I want this one. This is a C++ decoding thing. Let's see what we feed it. Yeah, we're feeding the entire ROM though. So let's see if we can inject our own round here. So round number, okay, so okay, so this just reads the data, right? And then we do parse. So around this round with round number, and we're parsing the round header. Round header, why? So round header is resized to 6, and then we're inserting the round data. Okay, so it's not just round header, it's the entire round binary data. And that's a vector of uint 8s. Okay. So remaining bytes resize. Okay, yeah. Well, no, round data. Okay, that's the base array which we are reading into it, and then we are inserting that into the round header. Okay, so round header is our data here. So all we have to do is create this, and then we have our round, right? So let's see. We're gonna ignore this for a while here, for a moment, and okay, I have to put some namespaces here, and then that's round number 1. Let's say. I think that's just storing the round number. That's not important. And then we just need the data, right? So we have a vector of uint 8ds, which we are going to initialize straight in the file here. and then we're reading that, and then we will just dump this around. Right. Let's see if that works. Now we just have to populate round data. If I do not -c, I have the values. Yeah, these are my values, right? So if I just copy this, and then we'll have to type a bit of nonsense here. And then OX, that becomes this, we have to copy, right? Oops. Yeah, that's our data, right? Let's see if that compiles. Okay, now let's execute that. Okay, we have a bug, because that's not correct. So no power-ups. 6A is also incorrect. That should be 5.8 or something. Yeah, that's 8.5 though. So we have 3 power-ups. We have Lolo's position, the exit position. Oh no, are we missing, or do I have an extra 0 here? Because 85 is the exit. Oh, I think I put it in the wrong place. Put the count in the wrong place, because 6A is our length, I think. That should be like 112 or something. 6A 106, right. I put it in the wrong place when I'm doing this here. Data 5 should be, which is 6th byte, or so we have 3 at the start, 3 power-ups, exits, Lola position, exit position, and then it's our size, right? So 0, 1, 2, 3, 4, 5. That's the 5th position though. That's weird. Like 3 power-ups, Lola's position. Oh, it inserted it. Oh, it didn't. This stupid thing didn't overwrite. Why? If you're indexing an array, are you not overwriting? What? But it is, because it overwrote the FF though. I mean, it looks like it inserted it before. Okay, something stupid is going on here. Okay, let me write out what is getting pushed though. Well, I don't have to do these because these are 0, but I'm going to add this. And then we're adding this. And then we're pushing FF. And then we are overwriting well, no, I'm not going to. So we're pushing 0, which is Lolo's position, and then 133 is 85, I think. 85, yeah, that's the exit position, x8, y5, and then ff, and then, okay, so let's get the hex dump. Do I not? Wait, did it not download? Yes, it did. What are you complaining about? Okay, so we're pushing 0, which is this one. We're pushing 85, so it inserted it in between though. Like, why would you do that? Why is this not overwriting? Yeah, because then we have 1 plus 8 is 2 8s, which is this one, right? So it swapped these 0, 1, 2, 3, 4, 5. Okay, wait. Let's see if I do not overwrite it, if my FF is in the correct place. No, it's not. Wait, am I doing this? Yeah, I'm pushing Lolo's position. Which is 0. And then 85. And then FF. What is this nonsense? Like, why is this FF not after the 85 though? Okay, I'm again doing something stupid because this doesn't make sense. I'm pushing 0 and 85 and then FF, and yet this stupid stuff gets inverted here. Oh, is this oh crap. Well, no, this isn't endianness, right? No, we're talking about 8-bit values here. Is it? Wait, are these so 85 FF? So 9 is 1 plus 8, so 2, well, no, 1 wall, then 88. So 88 becomes what? That's bottom 3 was count, I think. So that's 1 time 88. What was 88? That's Lolo again. Okay, that doesn't make sense though. Oh, no, yeah, that's the first byte. Okay. Oh, yeah, they are flipped. Because it's 88 and then 09. 09 being 1 plus 8 is 1 times 8, which is, or 2, because we're adding, 1 is 2 walkable spaces. Yeah, they're inverted because of endianness. Crap. Why would it do that? Like I give it a straight array and it's messing with endianness here. That does not make sense. Typed array views are in the native byte order of your platform. With a data view, the byte order can be controlled. That's interesting because I don't really want to deal with endianness though, especially in the browser. And there's no conversion going on. That's messing up stuff here, right? Where are we? Right, so it's just doing this, all right? Do I have to go over new blob though? What is this file thing? Can I access these? What is file bits? An iterable object that will be put inside the file. Okay, and what properties do we have on file? No way to download this stuff or what? Create object URL, okay, sure. But yeah, so we have an endianness problem though. Little endian is least to most. The typed array guide provides an example that converts any number to its binary representation under the given endianness. So yeah, if I give you this, I do expect a big endian one though. Let's see what this is. Well, yeah, that's the data view, but that's what we just read, right? So that's all good and well, but can I feed this to a blob though? That's the question. So we had to put a data view on the array buffer. Okay. Like, what's weird to me is that, well, no, like over here it's still correct, right? So the FF, like it is actually overwriting the FF. So that is definitely correct. Otherwise, it wouldn't. It would still have the FF in the dump, right? Which it isn't if I overwrite it here. So the 5 is correct, obviously. It's just is doing a stupid conversion, an endianness conversion here, by actually downloading the file. And of course, if I compare the two, they are identical, right? They aren't flipped because I didn't look at that in detail, but I think they are exactly the same. right? So 133.106, 136.908, like that's 85, and that's the length. That's 88, and then 9. So the order is perfect. It's just messing with the endianness, which I didn't ask it to do. Like even the uint data array is correct. Of course, no mention of endianness on the blob page. Like, okay, so typed array is a view into an array buffer, that's fine. And a data view is another view in an array. Okay, but which allows items of different size and type. We don't need different size of type, we just need the endianness to be. So I'm assuming you can pass a data view to this blob constructor as well. I mean, is that the case? Blob parts, iterable object, array buffer type, yeah, or a data view. Okay, sure. So can we make a data view with a specific endianness? But we can also write 2 bytes at once using a uint 8. Oh, but okay, we're dealing with an 8 array. Like that, even it doesn't even matter. We're not talking about 16-bit numbers or anything, and yet it does mess with my data. Like, okay, so that stupid stuff has been inverted. Okay. The answer is that order is endianness. Okay, sure. I want to force endianness though. Show me how. Is set is little endian and a property of a uint array or a typed array? Okay, write an entire article and do not tell me how to change the endianness. Good job. Did they actually wrote an entire article without saying how to change the endianness? Yeah, because that would, I mean, I can look in data view though, see if that mentions it. Endianness. Use data view. Okay. Do you show me how? Oh, okay, it's a true. Okay, sure. So let's try. Create a new data view over data. Does that work? No, let's use the uint8 array, and then what do we have to pass here? Set int 16. Oh, it's using the set functions to specify whether the. But why are we discussing an endianness in an 8-bit array? There's no. It's 8 bits. It's bytes. We're not talking about set int 8. Like set int 8 doesn't even have, like, that does make sense, right? So only the 16-bit and the 32 stuff have little endian nonsense, because an 8-bit is an 8-bit value. It's a byte. Why are you flipping it? Like, what sucks is the endianness is defined in the set function, and I do understand that. But then why touch my byte array, my uint8 array, when you're writing it out, though? Like they mention that NDNS can be controlled by the data view. Well, data view accessors provide explicit control of how data is accessed. Okay, sure. Regardless of the executing computer's NDNS. But yeah, I'm doing set int 8, an equivalent of set int 8 though. Okay, Google giving me results without the words that I want in it. Okay, yeah, that is sure. Sure, let me just flip the bytes manually. I mean, it might end up being that though, as the result. Great. Like, it is reading these as 16 or 32 bits values though, and I think that's the problem. Oh no, it's like uint8 blob. Right, so 68 is H, I guess. Let's see, H. Yeah, that's 68. So here we're not flipping the bytes, right? We are creating a blob from the uint8 array, which preserves the bytes, and it prints hello instead of EH, LL, or L, and then O. So it doesn't flip the bytes. Why does it flip mine? Right. So I want to try this, like, because I don't believe anything anymore. Of course, this becomes an async function. I think we need async function here. Okay. What are you complaining about? Okay, no, data view. Yeah. So yeah, it preserves the order, right? Why does it not preserve my order? Okay, I'm gonna double check with a different hex editor, because if hex dump is messing with my data here, which it is. Okay, I think it's hex dump messing with my data here, and that would be annoying because that would have meant that all of this was for nothing. So I'm going to remove these guys. We don't need. We know it's written in the array. It's in the correct order, so that's fine. Okay, so I'm gonna get a fresh puzzle export here. Right, so I have a puzzle export. My hex dump is incorrect. Right, it's 6A85 instead of 85. Oh crap! This stupid thing. It is correct in the file. It just, if you do without -c, it flips the stupid endianness. Like who, why, how? Stupid stuff. It was correct in the first place though. That threw me off. Like why would you expect that to, like the -c to do the thing here would not flip the bytes, like, or would flip the bytes? Stupid stuff. Oops. Can I do it like this? No. The next one here. Okay, I cannot do it like this. Okay, so we have 3 power-ups: low loss position, exit position, the length, and the data. 88 first, yes. Okay, so this is correct. Like, that was a waste of time. Where is my thing here? Yeah, okay, so that works. That's correct, right? You see Lolo at the top here. We have all the way down. We have snakies. Yeah. Okay, that does work. Okay, that was a nightmare. Okay, never mind. Okay, so our horizontal algorithm works. Now I guess we'll have to do the vertical one, which is a bit more difficult, but fine. Actually, I'm going to do the same thing where I determine the smallest of the two and then write the smallest out in the data, so I can't push here. We'll keep track of a separate array, and then we don't need to keep track of the bytes written, because we'll just know the amount of data in the array, right? So we don't need this. And then we'll say our horizontal data is an array, and we will push into that. And then well, no, we already know this, so that doesn't matter. We know the length of the horizontal data, right? And then we do the vertical algorithm. How do we do this? So we have to go top to bottom and then left to right. Let's see, in the algorithm in the C++ side. what do we do here? So the vertical algorithm, well, I just have to think it out though, because like we can't really compare decoding and encoding at the same time here. So yeah, all we have, let's think about this. So we have to go from top to bottom, meaning we have to keep track of the column we're in. And we have to loop the board size amount of blocks. And then we do the exact same thing as here, right? It's the same check. So it's just what we feed, what current block is here. That's our input that we get to feed. Okay, so let's try. We are going to have to loop the column count and then the row count, right? So the column count first. Let's call that for let y equals 0 and y smaller than what did I call this? Board width. Okay, so we are looping our y, and we have to do it for every x, right? So yeah. Wait, no, we have to do the y needs to be the x needs to be constant for every okay, it's x first and then y. And then the current block is, of course, the combination, right? So let current block equals blocks y times the width plus x. That would be the block, right? The current block. I'm gonna scope this so I don't pollute my namespace here. I think that works in JavaScript as well. We have a previous block and a current count. We need both of those. Okay, let's see. So yeah, we have to assign at the end for sure. The current block is the correct position, right? So seeing as we are looping over x first and y second, meaning x stays the same, so we're going top down first and then to the next x, right? So we are moving vertically now. I think it basically comes down to the same algorithm as here, right? So if the previous block is not null and we have a maximum of 8 and it's not the same, yeah, that's going to be the exact same thing, I think. This goes away and then the current is being kept. Yeah, I think this is the same. So now let us, yeah, we have to push. Okay, we can leave this out and we just push our length after our two algorithms, meaning, oh yeah, it depends on which algorithm though, because we have to set the top bit for the vertical one. So let's data length equals 0. Why is data length known? Okay, that doesn't matter. And then we set the data length to the horizontal data length here. And for the vertical one, we set the top bit as well. And that basically comes down to adding, what is it? Just adding 128, right? Yeah. I think that makes sense. Yeah. So now we set the top bit and then we can just push the data length, including the algorithm. And then we add our, well, okay, so we have to do we have to assign it based on the actually we'll have to work on this because I have to compare both data lengths, but of course I can't compare it with the 128 at the end here to see which one is bigger and which one is smaller, right? That would make sense. I'm going to assign simply based here so we can concatenate these these two arrays, right? So data is data.concat block data, and we're writing that to the file. Okay. So now we have the vertical algorithm, which we're failing in. Horizontal data is not defined on line 878. That should be vertical data, of course. Okay, sure. Yeah, I did make that a const for a good reason, but that's fine. Okay, let's get rid of, well, I mean, I can do it like this. And that seems way smaller. So we have 85 and then A4 for the length, 88. Okay, so now let's see what the original was in the game, right? Because that should be the same. First 5. That's not the same though. Well, maybe. OF 08, 07, 0, 20. Yeah, it's the same. It's the same. A8, 38, A8, OB 04. Yeah, and the length is A4. That is different. This is A5 though. Why am I missing? Oh, yeah. Forgot about this. We're not dumping the last one. Yes. I did think about that a while back. Yeah, so this is also wrong, as you can see. This last one isn't taken into account. That's a wall, a 0. But it's this hard framer with bullets. So it should be an A8, same as this one, which is this one, right? Yeah. And I'm forgetting that because I am not cleaning up here. So after the last thing here, I have to write the last value. I think I just have to do this, right? And for this one, I have to do the same thing after the last one. Okay, no, also this is wrong. This should be outside. Oops. Yeah, this can't be in the loop though. And vertical data push should be here. Does this influence the length? Yeah, no, that's fine. It's squaring the length of the array. Yeah. So let's export this one and see what we get now. Yeah, so we have an A8 at the end and our size is now A5 and it should stop with A8. So we have a length of A5 and our last thing is A8. Wait, it's not that one. 20, 41, 20, 41, 0088. And then we have 3 power-ups for the next level. Okay, yeah. So that's now like completely identical to what they have in the ROM. That's perfect. So that means our algorithm does work though. That's very good news. Now what I'm going to do is compare the two sizes and take the smallest one. Let us, yeah, I'm not going to do this. I'm going to extract this from the scope and this from the scope. because I have to do them both anyway. I'm not going to calculate the length here or assign the length. And now, after these two, we are going to compare the length. If the horizontal is smaller than the vertical data length, that means we're going to use the horizontal one, meaning we are going to push the horizontal data length without any manipulation, and we will concatenate the horizontal data. Else we'll take the vertical algorithm, meaning we will add 128 to the vertical data length, and we concatenate the vertical data length. Data. Okay, so that should now always give us the smallest of the two. So let's see if it does that. Test 3. Yes, it does. And now let's go look at level 2. That also looks to me like if the vertical algorithm is more efficient because there's more vertical consecutive lines of the same block as is horizontally. So I'm assuming it's going to give me the same vertical algorithm. Let's look in the ROM data. So we have 8288AF being the size, I think. Yeah, and it's the same, right? OF, OB, 07, 09, 40. Yeah. That's perfectly identical. And we're stopping here with OFOC. Yep, and then 3 power-ups for the next level. Okay, so we did figure out the reason why they have 2 algorithms now. That's pretty much confirmed, right? That's because they're trying to optimize the space in the ROM, which is limited, to pick out the smallest size. Now this one is interesting because this size should be identical pretty much horizontally or vertically. Like they positioned it here, meaning if you go top to bottom first, would result in the same thing whether you're going or if you're going horizontally first, right? Because you have like 11 blocks plus 1 and then you have Lolo, or you have 11 blocks plus 1 and you have Lolo. Same with the exit, right? So it shouldn't matter which one you choose. So now we will know which one they would have preferred. If it's different, then like we will be preferring a horizontal, I think, right? Because, wait, let's see. No, I'm assuming the lengths will be equal, so we are going for the vertical one. Okay, let's see what they did and what we are doing. So test 5 now has, let's see. So we have 3 power-ups, Lolo position, exit position, and then 99. 99 being the length. Let's see, the top bit is set. The top bit is not set. Okay, I want to dump these lengths. That's curious. Why did I not? Oh, there is a difference in length though. The horizontal, oh no, I'm on the wrong level. Okay, wait. It's this one I need. So yeah, 25 and 25. So there, it makes sense, right? The level is purely symmetrical. So whether you go horizontal first or vertical first for the run length encoding, that doesn't make any difference at all. So they end up with the same byte count for the encoded level. So if that's the case, so horizontal data is not smaller than vertical data. So we do go here though, meaning we do add 128. So why is my top bit not set? That does not make sense. So what's the latest one? 7. So we have 3 power-ups. We have Lolo's position, we have the exit position, and the length, 99. Okay, I was in decimal. Okay, that's why. So 99 hex does indeed have the top bit set, right? And now let's look in the ROM and see which algorithm they chose. So it's the third level, which is this one. 99 is the length. Oh, no. So it's 3 power-ups, low loss position, the exit position, and then the length. So they chose the other algorithm because 19, 19 hex, right? So we have 153 and 25, right? So 19 hex is 25. So meaning they did not set the top bit. So they use the horizontal algorithm. So let's change that. So we are exactly the same as the original code, right? So we just have to swap these. Right, if the vertical data length is smaller, then we do vertical first. Okay, so now if we export level 3 here, and we go look at 8, now instead of 99 here, we have 19. Yeah, so now we have a horizontal algorithm, and the rest is the exact same. Okay. That does make sense. Very good. Now, what do we do? Okay, we need to look at this header though, and this bothers me because we don't really know what these mean, and they differ though. Like the D6 is like 14 bytes less than, wait, why is it C9? Well, it's C9. Yeah, C9 is like here, and that is consistent over all saved files. So I don't know why that is the case. It's like 14 bytes off the end, and I don't know why that is exactly the case, but sure. So we have implemented our export, right? Do we have a console log in there? No. So let's commit that first. Right, so we have our link here. That does work, that's fine. And then what do we have here? So we have an export button we added, and then we have our export algorithm. All right, we do both algorithms. We choose which one is shorter, and we download the file. Oh, no, wait, I need to download all 5 of them though. Yeah, it's not finished, but like we do need to do it for 1, 2, 3, 4, and 5. Now I'm just doing the current level. But if I export, I need to create a disk, well, not necessarily a disk image, but I need to create this file, this PZL file, the puzzle file, with this header, which we have to reverse engineer first. But yeah, that doesn't really matter. Okay. So that's done too. Right, now I have to figure out what that data means, and that's not going to be easy because I don't know where these values end up, right? So we have to look in the code here. That means that I also have to load a different machine. I want one with a disk drive. And then we have our disk that we have to load. Okay, and then we have to load the ROM. And now we have to see where that cassette or that disk data gets loaded, right? Okay, so we can load a file from disk. no such, okay, no such file. Do we not get the, yeah, yeah, we can do a list of the files, right? So first 5, I guess. So first 5 is the one we have to load, but I need to look in my symbols to see where the disk data gets loaded into memory. I think I made a note of that. So if you look at the symbols here, I think I might have this construction tape or disk. Okay, I don't have anything related to. I think I've seen this though, but I have to look at. Let's go to the construction data area. That is, yeah, it's around these file names and stuff. D926. Let's go look there. Right. So I think, yeah. So my file name, first 5 powers. So it has loaded stuff here when I was listing the files on the disk image, right? So I think if I actually load now, it should load the contents of this file, which is this, into RAM. I hope, at least. We're mostly interested in this header, right? So let's see if that actually works. Yeah, no, it doesn't do that at all, which sucks because I was hoping to see that data here. And I don't think maybe we can find this if we do search for it. Can we search in the memory here? How did we do that again? Was it a cheat thing? Can I find a value here? If these are not flipped, right? I think these are in the same order. I mean, we can check though. Search for, well, no, I don't want a specific value. I want a hex value though. So yeah, we can't really search here. Let's go look in the, so this the 8F5, I think. Are we here correct? No, what was it? D5F8. Yeah, that's the, yeah, so this was overwritten. We can actually see if we put a watch point here, a write one, writing to this, that would be overwritten as soon as I load a file though, right? So if I do a load here, then we do break this. So this is a routine that then writes the disk data onto the, overwrites the ROM, well, not ROM, the first 5 levels in RAM, right? So it should reference the disk data here. And where is it loading from? So it's in the accumulator. Wait, it loads 54 into what DE points to. Okay, does that make sense? Oh, A is 0, 0. So A already has the first power up. Okay, good. Yeah, and we're loading we're loading the pointer to the first round here. That's this one. But the question is, would it start here? D92E is also in play. D92E. Which is F8D5. Okay, so that is, oh, this is interesting. F8D5 is in our file. So F8D5 or like wait, is it F8D5? Well, it's inverted D5 F8, right? You have to flip them. It's Indiana stuff. D5 F8 is our pointer to the first level. So does this mean, and this would be awesome, if the pointer to where the data has to be written is in the file, because that would mean that I could make a puzzle file that overrides not only level 1 to 5, but level 6 to 10 and 11 to 15 and stuff. Because I have the pointers. I know where the pointers are. That's just this pointer list at the very top of the ROM. That's fine. We have all the pointers. That would be awesome if that is the case. So is that the case? So D92E is written into DE, right? Yeah, which is in DE, D5 F8, which is our pointer here. Which is the value, I don't know where it was. Where was it? D92E. Oh yeah, it's this one, D92E, right? So this is yeah, these two guys here. That would be the pointer. And where are these written though? That would interest me very much. Unless, of course, well, it's why would it be in here, right? D5 F8. I am going to try this though, just to see. Oh no, wait, no, I can't. I cannot write the level 6 to 10 and stuff because they are in ROM still. They're not in RAM. Only the first 5 levels are in RAM. But it is weird that that pointer is actually in the file though. Like, why would that be the case? And D6 is the file size -1 though. It's also weird why it's -1. So FE might be, okay, it's comparing with FE. That's the first byte we have here, right? And then I mean, this might be like a magic number, and then we have the pointer to where to write it, and then an unknown. Well, 2 sizes, right? Does this C9 is like 15 bytes or something from the end, and then D6 is the length -1. Let us break here and see if this is the start of the function. Like, we have a return here, so chances are that the load function starts exactly here, right? So let's do that. Let's let it go so it can load. Let us remove the right watch point, and let's reload the level. Okay, so it looks like we are starting here. Our stack has A4, A7 as our calling thing. A4, A7. Okay, well, that's a return. Okay, that's fine. The load map data into current. Okay, sure, that's fine. That's fine. But it is a return though, so I don't know if that's relevant. Okay, so what do we have on in our values here? We're pointing to F8 6C, and D5 F8 is already okay. That's probably not overwritten from the last time, so that's fine. But we have F8 6C. That is a large number though, so that does surprise me a bit, because I don't think that's a pointer to anything relevant. F86C. F8, that's way down. That's not going to be anything. F8, 6C. Yeah, no, that's, well, I mean, it does have first 5 here though. Do we have recognizable data here? Like we're in the basic stuff here, like that's not, this is like not relevant, I think. So we're calling something A76B. That's this one. Immediately calling something else. I'm not going to worry about this that much. I mean, it calls 2 things. D932 is loaded. That is also relevant because we're in our construction loading stuff, and this 01 is being loaded. So that might, and 940 as well. So yeah, we're loading several values here though, but we're not going to worry about that now. That does take a while though, so that might be actually loading some stuff from disk perhaps. We are not taking this jump, so this does something, and this might be like a header check or something, not sure. That doesn't really matter yet, so we're not taking the jump. So D92E is our pointer to where we have to write the data, right? I wonder if this one has been written yet or overwritten by this call. That could be the case though, which would imply that the header has already been read here, because yeah, so because we're going to compare stuff here, right? So so we're loading that pointer into DE, that's fine, we're calling something, and that is indeed FE. So I guess that would be this FE here, right, that we're comparing. And what do? We do not jump. So A697 might be like a bail function, like A697 is this. Yeah, that's after the return. Okay, so it jumps out of this function. So can I force this? I don't think I can. Yeah, I can. Let's force this and see what happens. Error, no such file. Okay, so this is an error state. Okay, sure. Like no such file. They only had one error message, right? Like it's not like can't parse file or whatever. So yeah, this is definitely an show error, show file loading error or whatever, because we're using the same thing here. So this does the header check, I'm pretty sure. So it has to start with FE because that's hard coded, and I think maybe this pointer F8D5 is loaded here in this function. Okay, so let's do this again. And now let's put a write breakpoint or a watch point on this one, and see whether it gets triggered while we're executing the first function here. So, okay, that doesn't matter. First 5, we load. It's before. Okay, that means, okay, yeah. Loading HL into D92E, HL containing D5F8. Okay, that means that the function starts higher up. So I thought the function started here because we had a return here, but our processing is higher up. So perhaps it does start here. And also it needs to be more higher up because HL has already been loaded with our value. And this says construction filer related. So that's D92C. We know this is related, but we don't know what it is exactly. Okay, so let's stop here then. Now, what's interesting is that we're loading or doing jumps based on whether we are on tape or disk. And I would have assumed that that would already have been known at this point. Because I did select my, like where is this pointer, where is this HL coming from? That's what I'm wondering about. So let's see if I can escape this function and see if this is set higher up. Okay, that's fine. Let's leave this out and load again. So yeah, HL already has D5 F8 in it though. Can we escape this function and end up somewhere? Well, our stack still points to A4, A7 though, so that's not a good sign. I want to escape this too. Yeah, I can't escape this function. Yeah, so A4, A7 is indeed where we... Well, unless this is the call though, A627. Yeah, this might actually be the call. So round 1 map data power up 1. Oh, yeah, of course. No, this is it. Yeah. So we are hard coding the pointer to load into that position. Okay, so call A627 is indeed the load the file contents function. Yeah, so this preps the pointer where we have to write the map data, and then we call A627. So that would be the start of the function. Yeah. So A627 is load file. Okay, let's put that in our symbolic symbols file. Okay, we have nothing at A when it comes to functions. No, that's quite low. Okay, oh, quite high. I mean, AD, A4. Okay, so that would be load load disk file. I mean, it might be tape or disk file though. Okay, not this one. A627. Okay, that was what I was looking for. A627. Okay, you can go away. Where are my symbols? Okay, so this is load tape or disk file with HL already prepared. Like the well, we have to break there, of course. We are running now, so no, we are not. So first 5 load. Yeah, so D5F8 has been written just above this, so that's good. I don't know why we are storing this again here though, but like fine, I guess. Like that's a bit of a waste of memory, but sure. So I don't know what the SP thing do. So let's see what SP means. So we have LD comma SP. Do we have this? Where is my search thing? Add SBC load NN. Okay, so it's this function. Yeah, okay. Stores SP into the memory location pointed by NNSP. Is that are those these two flags here? 1 1 into construction file related, which is D92C. This one. So if we do this, no, that's 37. Oh no, SP is this, of course. Yeah, it's DE37 is being stored here. Okay, I don't know what DE37 is though. That's our SP register. I'm not sure if there is an explanation for what this is specifically used. Okay, this could be peripheral stuff. Which would make sense because we're reading a file from disk, right? Okay, it doesn't really explain. Oh, is it a stack pointer? Wait, what? Oh yeah, this is stack pointer. Okay. Oh wow. Okay, sure. Yeah, we're saving the stack pointer like DE3. Okay, yeah, sure. It's DE37. I didn't see that. Yeah, so we're storing the stack pointer here. That's a bit weird too. Okay, sure. But I guess that's not really relevant though. So we're loading HL into D90. So we're saving the stack pointer. We're saving our pointer to where we have to write the data to round 1, and whether it's construction of, well, we're checking, right? So right. Okay, so this is for tape, and this is for disk, right? So we are taking a jump. So we're not doing this. This is for tape only. So this is for disk loading. Good. Right. And then we have our A76B. So it makes sense that at this point in time, we did not read anything from disk yet, right? Which I think we're doing here because we're comparing FE and stuff. Like, yeah. So let's dig deeper in A76B. A76B is this one, which we're immediately calling something else. Yeah, we have to dig in though. A744. A744 is this one. We're looping here. We're doing a little loop. So let's see where we end up. Okay, that's the first one. And then we end up at A744. Okay, so we're setting A to 0 and we're loading D932. So do we know what that is? Yeah, we saw this value before though. We're loading that into HL. Oh no, we're loading the pointer to D932. Okay, we're loading the value 25 into B. Let's see. 25 hex is 37 decimal. This is the amount of times we have to do this loop. So we're doing something 37 times. Okay. We're loading the value of A, which was set to A to 0. Oh, we're clearing some. Are we clearing something? Into what HL is pointed to D932 is going to become 0. right? We're increasing. Okay, so we're clearing 37 bytes here. Is what it looks like. I thought we had instructions to do that though. Why are we doing it this way? So yeah, we are clearing this entire thing out for some reason. Well, I mean, I guess that makes sense though, yeah. So we have to clear all these out. So let's jump to here. So this should be clean now, right? So we have 25 hex bytes worth of data. Okay, that's clear now. I mean, we might be loading the header in here now though. That's not 37 bytes, but sure. Again, checking whether it's going tape or disk, which is weird because we're already checked that and we're in the disk section, but sure. Okay, so we are in, oh, and we're writing that to 932. Okay, sure. Right, so this means we are now in disk mode. We're loading a couple pointers, F866. I'm going to look at that in a different memory editor. What was it? F866. Let's point into the file name. Okay. Oh, this is clearing or copying memory. Right. It's copying the file name and then copying something else in this space. Sure. Right, so we have a pointer to the file name. The destination is D933. Right, so it's going to put first 5 in this thing here. Okay, so sure. Right, boom, there it is. And then we're loading A768, and we're going to copy that to A768. That's PZL. Okay, that's the extension. Sure, we're preparing the file name in that thing. Yeah, so we have first 5 and then space PZL. I don't know why it's space, but sure. Okay, so that function A744 is load file name. Into D932. Like, okay. I am going to add that though, so I know I've seen this. Okay, I'll clear down the last of these ones. So D932. Oh, right, D93. That's weird. I'm gonna go back once here because we did write construction tape to D93. So we're overwriting that D932. Right, so we are writing construction tape or disk onto D932, but then D932, that's a copy of this one. That's weird. Yeah, it's 33 that gets the file name. Okay, so this is simply a copy. Don't know why, but sure. And then we have construction file name. And then with the puzzle extension, okay. I don't know, I needed to add the function as well, A744. We don't have an A7, okay, but that's fine. Get file name. Is A744. Okay, that's also clearer now. this is high up. This is a BIOS, well, not maybe necessarily a BIOS call, but because the BIOS calls are low though. Like, I'll have to look at this one. So we got a file name prepared. Well, no, let's call this get file name to load from disk though. Not necessary from disk, but yeah. Right, so we are loading this copy into DE. D932, sure, well, the pointer to it at least. And then we're loading OF into C. And then we're calling this function. Okay, let's see. So I think this is actually going to read the stuff from disk now, because we've prepared the file name, which we are pointing to in DE. HL doesn't really point to anything relevant at this point, I think. And yeah, C has OF in it now. Sure, F37D. Let's see what this is. F37D is this one. Okay, we're jumping to F331. Let's see where we end up. F331. Okay, now we're doing BIOS stuff, I guess. Reset. I assume that means reset. Okay, reset 30H. So the current PC value +1 is pushed on the stack and then is loaded with 0. Oh, okay, so we're saving our PC program counter and +1, of course, yes, and then it's loaded with 0. Oh, that's interesting. Yeah, and we're doing what is ADC? Like, this is loading stuff from disk, right? Adds the PC and the carry flag to HL, sure. And then out to A. Out of a value to A. Yeah, to port 56 hex. 56 is MSX. Okay, that's incorrect, and at least not. That's weird though. Like, what is MSX Pi? Okay, to a Raspberry Pi. That's quite interesting though, because of course that didn't exist back then, right? But sure, I mean it's doing external communication. Like, that's fine. I can run here and then return, right? So we don't have to worry about this, right? It is loading stuff. Oh, and it didn't give me control back even, right? So sure. Well, that's fine. Let's start again. Okay, where were we? It's not, well, it's not this one, it's this one that we were looking at, right? A76B, get file name. Okay, so we have to end up here. Right, so after this one, okay, no, get file name is fine. I don't want to break here anymore. I guess we have to do that again. So yeah, we can stop here and then go in. We don't need this. That was just get file name, right? So this just, oh no, it was this one we were looking at. So let's see what that ends up with. Yeah. So this is after our specific call to the operating system. And then do we have something interesting? Right, I don't see anything that changed. So we're loading 1 into HL and putting HL in D940. Okay, so this becomes 001. 16-bit, yes. We're adding A and returning Okay. Okay, I haven't seen anything reading these first bytes yet, so it's not really relevant, but that's fine. So we return, and we do not jump. That's fine. Okay, so we did this. Now let's look. D9 to E, already also an unknown. D9 to E. Oh, no, that's the pointer to, yeah, let's give that a name too. Where's our symbol file? D9 to E. This is construction pointed to round 1 data. That's for loading, right? So yeah. Yeah, that's this one. Okay, and we're calling A6 B6, but we're calling this multiple times though. So is this get byte? Like, because we're calling this 1, 2, 3, 4, 5 times, we're calling this 6 times, well, 7, I guess. And the header is, of course, how long was the header? 1, 2, 3, 4, 5, 6, 7, 8. And then we start with the power up data. So we have 8 bytes. Well, let's see what A6 B6 does though. I'm thinking A6 B6, this might just load a byte and return, right? So we're calling a high function again. F3, okay, yeah. Let's see what this does. Sure, yeah, that's still here. So we're loading the pointer in. Okay, that's interesting too. So we're already loading this pointer. I wonder if that's going to be used in A6 B6 here. Okay. So we're pushing that on the stack, so probably not. Yeah, no, because we're overwriting it immediately. So we're loading whether it's a tape or disk, the copy value of it. We're loading 1. Oh, right, so this has to be passed through that higher up function to that BIOS function, I guess, to see whether it's disk or tape. Okay. And then 1 and 27, sure. We're loading stuff. The question is, do we store something somewhere though? Yeah, we did chains here. I mean, this FE might have been changed. I don't know. Although that's a different file though. Oh, is this index 27 into this array? I don't think so though. No, it was only 25. Okay, no. And we're loading, okay, D957, which is this one though. So we have to look at this one again. So let's see if D957 is the first byte. D957, because if that's the case, then this function is actually loading stuff, right? So I'm going to let it go. Of course, this is going to, I am curious, F8 is the next one. Yeah, this is a read byte, because now it's F8. Yes, this definitely is a read byte from disk, or read next byte from disk. Well, depending on the parameters, I guess, on the although maybe actually it was doing like six after one after the other, right? It might just be skipping them and ignoring them. Okay, let's see. I'm going to disable this one, A6, B6, so I can continue. Okay, now, yeah, let's put this away on 0, and let's see what happens if I load this for the first time. So I'm going to continue. Right, so now, well, no, let's not do this. Let's just skip over it and see if it's gonna load FE in this byte. I'm pretty sure, like, yeah. Oh, and is this the count? Is this our byte count, perhaps? D953? That could be the case too, though. So we're comparing with FE. That's like a magic number. Like, that's the file magic number. Again, A697 is being jumped to. That, I think, was the failure thing. Yeah. So this is an show the error message. Well, I mean, I guess I have to add that one too, right? A69, okay, that's fine. Well, show file load error message. That's A697. All right. So yeah, that has to be FE. That's like the magic number, the magic header number of the file. It has to start with FE. And then we're literally skipping like 1, 2, 3, 4, 5 bytes, 6, I guess, because this doesn't really, unless that gives. Oh no, it returns it into the accumulator. Okay, sure. Right. So it gets written here temporarily, and it returns it into the accumulator. Okay, that's good. Well, yeah, of course, because we're comparing it. Sure, of course. So we're loading F8 now, which is the file, right? F8 is the next one. And we're skipping over it. We're doing nothing with it. This is quite interesting because, so we're skipping over a couple bytes here. This might imply that they intended, in 1985, they intended to have the pointer on where to write the data into RAM into the puzzle file, but then came to the conclusion that they didn't have access to enough RAM because they would have had to copy like 115 levels into RAM from ROM, right? If you want to make all of them overwritable, and they didn't do that. They only chose the first 5 levels. So they might at a certain point have thought, yeah, we have to put the pointer on where to write the data into our puzzle file if we want to do other sets of 5 levels that we overwrite. That's quite interesting. But as we can see here, they just ignore it. Like, these values don't get used. And yeah, that's indeed the counter, the position where we are reading in the file. Because yeah, that's D5, C9, D6. So what is on D6, C9 though? That's because that's also a pointer, I assuming, that they intended to use. D6, C9, that's unknown now. 0, 0, 0. That looks like a, wait, that looks like a round data though, because that's 3 power-ups. Yeah, this looks like level data. Wait, okay, no, yeah. So this is round 1. Maybe that's the last one, I don't know. So wait, this is, what was it? D6, C9. Like, is it starting pointer and end pointer? So we have the first level, the second level, the third level, the fourth level, fifth level. Fifth level is this one, and that's this one. Yeah. This is start pointer and end pointer. D6, C8, well, C9 then, I guess. This is start and end pointer. Yes, right, because it's the first 5 set of levels, right? The first 5 rounds, and they start here at D5, F8, which is D5, F8, and it ends at D6, C9. Like, we have Indian shift here. which is here, D6, C9 is the max pointer plus 1. That's pretty cool. So now at least we know what these two things are, right? So we have a magic number, we have 2 pointers and a couple zeros. I'm gonna have to give this one a name first though, before I forget. D953. This is not the first byte, but this is construction current byte index. So we are reading this byte per byte, of course. Oops. Okay. Okay. So we are reading D6, and let's see what happens with these next 3 zeros, because those, I don't know what those do. Like we've seen one puzzle file with this being FF, 00FF. I've seen that, but I'm not sure what that is. So yeah, we have our first 0 now, and we're loading that into the L register. Okay, right, that's this one then, sure. And we're loading another one, and we're loading that in H. Okay, so that's a pointer 2, which points to 0. Okay, sure. Oh, and we're loading that value into FCBF. Okay, so this is another pointer that gets loaded into FCBF. So what is FCBF? Also very high up. Yeah, that's going to be difficult to figure out. Do I not have any? Yeah, that's and it's just 2 zeros, right? So I don't know. And then, okay, so we're writing that. That doesn't change anything, of course. And we're ORing L, and we're not. So okay, A67E. Okay, so we're skipping. Okay, we're skipping this here. Around 1 map data power up. So that's the pointer. We're skipping loading that. So these two, at least the L1, which is the first one, determines whether we skip loading the pointer into DE. That's weird. So we don't jump and we do load the round pointer into DE. We're loading another byte, which is the third 0 here, the last one from the header. Right, that's 0. Oh, and that also determines a jump, A68F. So we're skipping here if we have something in there. Interesting. So we are doing the thing here. So we're not skipping this part. We're loading the accumulator into our pointer here though, to our level data. D5F8. So now we're starting to overwrite our data. Well, it looks like this is power up related then. That's a bit weird because the power up data is here. That's these 3 first bytes, but we're still like doing something with these guys. Yeah, so we're loading A, but that doesn't do anything. And then loading E00 in HL. Ending with A, sure. We're not jumping. Okay, so and we're done here. Because this would have jumped here. Oh, did we make that jump? Oh, right, this is loading the data. Right, so this is actually loading the level now. I mean, it's still 3 zeros though, so it's hard to see. Now the next one should be 85. Which it's still not. Did I miss one? Yeah, now it's 85. Okay, I was one off. So yeah, we're starting to write this data here in these levels though. So depending on what is here, we do not load this level. That's a bit weird. So, right, so this OR, right, it does a test on this OO on these two zeros here. If something is up with those, we do not load round one map data like this pointer here. I guess we don't have to mess with these values though. Because yeah, now we're just loading the data into the level. Right, I should make this relative jump green because this always happens. So yeah, so the zero flag is being tested here, A64F. That's a bit weird though. Why is it that's over here? Okay, that's the return. Okay, sure. That's the end of loading all the data into our round data here. Yeah, it is a bit weird. So let's see what happens if I mess with this this stuff here. So let's continue. Actually, I can mess with that without having to change the file though. So I'm going to mess with the values in memory here. So let's see. So this is the first one gets read, right? That's FE, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, the 0 is part of that. Okay, and that 0 gets loaded into L, and the next one into H. So this is the HL register. Sure, that gets written. Right, that's these guys. And then we're loading 1 byte here, which is this one, and that surprises me because that's this call, but it gets reused for writing or copying the data. So what would be different? Okay, I need to stop here, right? Actually, let me just follow along with from the start here. That's easier, so I can track better. So first 5, we can skip. Yeah, yeah. So let's look at our where we are loading the data though. Wait, did I not give A6 B6 a name? A6 B6. Oh, I thought I, wait, did I not give this a name? I thought that was read one byte though. Wait, did I not do that? That's crazy. Weird. Okay, so we're loading the first byte. Yeah, let's get the bytes here. So FE is the first one, right? No, don't step in. Okay, so we have FE, that's correct. That's the first one. Show an error message if it's not FE. Then we have F8, D5, C9, D6 in the accumulator. They get returned, right? So that's okay. We're here now, and we're doing another one. So now we're doing this first 0, and we're loading that in L, and then this next one in H. So these two are done. That's the first one, and that's the second one. In H, we're storing those two zeros in far away, FCBF, and then we're ORing L. So let's see exactly what that does. Bitwise OR on A with L. Okay, so it's with the accumulator, so it does check. Okay, what does it return? Wait, let's see which flags it sets. Z and S as defined. Okay, that doesn't really tell me anything, but sure. So bitwise OR on A with L. Okay, just OR the values. Okay, sure. So that would just, if they're the same, okay. Oh, it's comparing these two then, right? Because we're doing L first, and then we're loading another byte, which then is the second byte in 8. Okay, so they have to be the same then, I think. Do we take the jump? So yeah, of course. So I think these two have to be the same, perhaps. If they're not the same, we're jumping to A67E. So we're not. Oh, would that mean then there's a potential for a third pointer here? The pointer would be, because we're skipping this, right? We're skipping this line here. If there is something off, right? So we're not loading the round 1 map data power up pointer, so the pointer to the round 1 data in DE. But I mean, to be fair, it already has this though, because D5 F8 is that pointer. Oh, so can we override here? Wait, but what I'm worried about is like we're having this information in HL though. We're not having it in DE. So if we do put a pointer here, it would get loaded into HL, and we wouldn't load anything in DE. But you would assume then that HL gets put into DE though, to use that as a pointer. Okay, so it doesn't matter. We're loading that again, that's fine. We're loading the next byte, which is on this one. Right, so now we are in the loop here because we are doing a relative unconditional jump to A67E. So this is our loop of copying everything into what DE is pointing to, right? Yeah, because we are loading a byte which gets into the accumulator. This accumulator gets to put in what DE is pointing to, and we're incrementing DE. So we're just copying bytes now. So yeah, even though this can contain a pointer, I don't see how this affects what DE is pointing to. That's a bit weird. However, this third zero, which is not part of the level data, because wait, am I wrong? No, I'm wrong. Of course, it is the first power up. We have power up 1, 2, 3, and then Lolo's position, and then the exit position. Of course, it's just another pointer. Yeah, these 3 zeros are not the first power ups. It's these 3 zeros, and then you have Lolo's position. So yes, this is the start of the data. Perfectly fine. Okay, sure. Right, and I did see this being FF, meaning that was the first power up. So if we go look at, I don't know which one it was, powers perhaps. Yeah. So that's why I was confused. So this is another file, a test file with power ups in it, and this one has FF here. And I was confused because I thought the power up started here, but they do start here. So we have our 3 pointers here. Yeah. Okay, so now let's mess with these values. I mean, these are getting skipped for sure, and this one is used, but not sure why. Yeah, let's see if we can mess with this stuff. So let's get ourselves a different puzzle. Let's copy the first 5. Let's just call it A. And let's open that in the hex editor. Okay, and now I'm going to put a nonsense pointer in this one here. And see if that affects anything. So we have to go to our disk manager here and copy we have to go to disk drive A and we have to copy this over. Let's see what happens now if we load. So this HL register is now going to have 5040 in it, or 4050 or whatever. And see if that messes stuff up. Where are you? Okay, I'm breaking. Okay, so file A, load. Hello, Utown Vector. Thanks for following. Welcome. Okay, so we are moving here. Right, this is all going to be the same, right? So we're just interested in the 4050, which will be happening around here. Right, so now we're loading 40, we're loading that. So the 40 is in the accumulator here. We're loading that into the HL register. Yep, and then the 50 comes in, and we're loading that into HL here. So now, oh right, we are writing that to a far off thing though. We're not sure what that does. And now we are checking whether L and the accumulator are the same, and they always were because it was 0, 0, right? It always has been 0, 0. Now this is not the case, so we're gonna skip loading this line here. But that's irrelevant because it already contains D5F8, which is what this line does. So I don't see the point. I think this is stuff they cut out because these pointers are skipped too, right? This guy here, these are skipped as well. So yeah, we are jumping now. We're not loading D5F8 into the level, and yet then we just start loading a level as normal, right? And like it's still working as normal as usual. So I don't know what it does, but I don't think it's relevant. I think this is because that stuff was reviewed, revised, and they didn't implement it. I think they intended to have the pointers here, start pointer and end pointer of all this data, where it has to go in RAM, and then came to the conclusion that they didn't have enough RAM to make all of the 115 levels editable, overwritable, and they're just skipping over that stuff. And maybe so. I mean, it has no points, right? They're loading the 4050 into HL and then doing pretty much nothing with it. Because we're loading the pointer to the round 1 data into DE anyway at the start of this function. So it already has the correct one. Now they do load different pointers, I think, though. Where are we? Yeah, so, this could be a reset because we start with the copy of the pointer, right? And then we hard code the actual round 1 map data power up. So there is a difference there. So what could trigger the copy, this construction copy pointer, to be different from the hard coded, the actual round 1 pointer, right? I mean, this is given to this file though. Like if we do load again, then we will see that HL contains the correct pointer, and that is immediately put in as a copy into this copy variable. So yeah, it's. I mean, I think we're figuring out that they tried to do some stuff and they stopped doing it because they didn't have enough RAM. Because it doesn't make sense unless we can escape this function. Can we? We cannot. Yeah, we can. Perhaps. Oh, did we stop? We stopped here on this breakpoint, though. That's not. Yeah, no. I want to disable this one. Like what calls here? Yeah, then we're again at this A4, A7 thing, which doesn't make sense, right? A4, A7. That's, well, yeah, that's this. Well, of course. Yeah, no. So this is hard coded though. Like we're hard coded loading that pointer into HL and then calling the load tape or disk file. Unless there is a difference between tape and disk, which I can't really test at the moment. So let's see, we're coming from 9FEE. Let's go to 9FEE. That's this one. Not sure, but yeah, this calls loads the pointer to the power up data, or to the round data into HL, and then does the load disk file function. Maybe there's a difference between tape and disk, I'm not sure. But at least we know that these 3 pointers here have no effect on the thing. So what we're going to do is write out simply all the values. Like, I mean, it can be zeros even. This can be all 0. And then we can perfectly load this file as well. So if we go copy this file over again, in the disk manipulator, it was already open. Yeah, if we overwrite that file, and we're loading this now. Did we break or crash? Okay, we're breaking, but that's fine. We don't need to break here. And we can continue this function. Yeah, so it loads it perfectly. And if we play this level, can we? To get my keyboard. Now we've loaded this level. And I think this will play just fine. Yeah, there's no difference. So these pointers are unused stuff. Okay, that's very good news, because now we can just ignore that. And when we go back to our file writing stuff here, we will simply output a couple zeros, and we don't have to think about that at all. So yeah, let's add the header here first. So we are going to push OXFE, that's our magic number, and then we are going to push 1, 2, 3, 4, 5, 6 zeros, which is the 3 pointers, the 3 16-bit pointers we can ignore, and then we do the data for all the levels, meaning we have to loop I guess they are 1 based. I have to change it. They're 1 based, but I have to change that to become 0 based. That's not good. And then this comes here. Yeah, round number and round number -1. Yeah, so let's do this 5 times, because we have to export all the levels, right? And then we write them all 5 out in 1 file. Let's see if that works. I'm going to make some changes though to the levels to see if we're actually loading the correct. So I'm going to move some stuff around here. Round 2. Let's make that a regular exit. Then round 4. And then, I mean, that's gonna not be able. I'm not going to be able to solve the level if I do it like this. Yeah, no. So I have to wait. No, let's do this. That's easier. And then let's remove these guys to make it even simpler. Okay, so let's export this. Okay, we have our test puzzle. I should have checked whether it's good first, because let's see the hex dump first. Okay, so we have our FE for as our magic number. We have 1 pointer, the second pointer and the third pointer, and then we have our 3 power-ups and the level data, and that should be, yeah, we have our levels here, that should be fine. Okay, let's see if that works. So we need to copy test puzzle into our disk stuff. That's not located here, but in downloads. Okay, let's see if this works. I'm curious. We need to control stop to go back to the menu. Select our filer. Go to load test. Why are you not typing? Wait, no, I need to put a file name though. Why can I not type? Okay, need to reset, I guess. That was weird. I don't know why it didn't let me type though. So select the filer. Why is it not letting me type? Oh, wait, no. I mean, test is in there though. Why is it not letting me type? Oh, is it because control is on? No. Okay, now it does. Okay, sure. Test load. We're breaking on a function, that's fine. Yes. So let's see. Our round 1 had Lolo in this position. I need to flip it still. It has to be mirrored. We have our exit in this position. That looks good. That's the only changes we made, right? So you have to go. I need to go to the round selector. Round 2. Round 2, I changed Lolo here and exit here. Then round 3, I changed the Lolo position and the block is now gone. And round 4, yep, that's also what I did. I put Lolo there and put the hard framer there. And then round 5, I removed the almas and put some caps in it. That's crazy. That works. So I can actually, I mean, they should be playable though. Like that shouldn't be a difference. But yes, that means that at least this works. Yeah, I mean, I can't finish this level because I can't push this block, of course. I didn't look at that, but sure. But yeah, that actually works. That's cool. So that means I can, I mean, I can. Oh yeah, what I can also do is, of course, I can load like an extra, like other levels here. If you want to play the higher up levels without clearing them. Right, and we can export that. And then I can just, no, I don't need a file thing. I need this. Can I F5? No. I'm gonna rename this though. Can I rename this? No, I cannot. Let's name that B. Oh yeah, I do have a refresh. B, let's load B. It's strange that I have to load. Okay, it's breaking, of course. Okay, that's because I put control on, that's why. So B load works perfectly fine. Yeah, that works. Yes. That's awesome. That means that it's pretty much finished. I do have to make a couple changes. I have to limit the amount of mobs you can add. But yeah, this is pretty cool. I don't know how to solve this level though, but that's probably already wrong. That's also wrong because I need an extra block. Yeah, okay, that's pretty cool. So that means that our export works. Let's see, what did I change? Yeah, I did the header that was irrelevant, and then I added the, yeah, that's the for loop. Oh yeah, that's everything, right? Yeah, I have the header, and I loop all the levels. Yeah, that's this line. Okay. So yeah, that reverse engineering of the header was useless, but we had to do it, of course, to know that it actually was not used, those first 3 pointers. But yeah, that means we can just put zeros there. Okay, so now one thing I have to do is limit the amount of mobs you can add in construction mode. That's the only thing I didn't do. I mean, it would be interesting to see what happens if I actually export it with without that limit. So the limit is, for example, this. If I go to construction mode, let's reset the machine. So we're in a clear state here. So what happens is, if I go to construction mode here, and I clear the field, of course I have to add Lolo and the exit, and I'm going to add a hard framer as well, otherwise the exit is immediately open. But we can only add, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Medusas. No 10 Medusas, right? There's 10, 3, 4, 5, 6, 7, 8, 9, 10. You can't put 11 Medusas in the level, right? Now I wonder what's going to happen. I don't have that restriction in my editor here yet, right? So I'm curious what it's going to do. If I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I wonder what it's going to do now. So if I export this, it's this one, right? C, and I go back to load this C file. I have to copy it first, of course. And we go to the filer and we load C. Let's see what it does. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is hilarious. So it doesn't do sanity checks on the stuff it loads. But this has repercussions though, because this might crash the game, not with Medusas, but with Almas and Golds. Their AI has only a limited amount of slots. Like there's 10 Alma slots, I think, or skulls, for example, right? there's 10 skull slots, so I wonder what's going to happen if we actually run this level. But let me not do it with Medusa, because that doesn't make sense, right? So so let's do this, and I'm not going to activate them yet. I'm going to want to do that manually. I wanted to, right. So let's export this. So this can't happen in the game. You cannot put 11 or however much it is skulls in a level. I'm gonna double check though to be certain. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and yeah, there's no 11. Okay, so let's export this one. So yeah, 3 by 4 is 12, right? So I wonder what's going to happen now. Let's load this level. Where are we? Open MSX. Refresh D. Load this one. No, I need to go to the filer. Load a D. Yeah, it does it perfectly fine. 4 by 3 is 12. I'm going to go to the game itself. Let's see what this does. I mean, it's going to be a problem once I start, when I finish the level, when the exit opens, because that's when the skulls are going to activate, right? So now it's not a problem. I can move around, but let's see what happens now. Yeah, the two stay dormant. It only does 10. Oh, it's confused. Okay, sure. It's doing it's doing one on the top left here. That's not normal. Yeah. So it is confused completely because there's only like 10 AI slots for the skulls, and it needs those skull slots to, or those AI slots to move them around. And yeah, that's not good. So I have to limit 10 skulls at least. It's like all of them are 10 and one enemy is 5. So I have to figure out which one that one is again. So how are we going to do that? I need to do a count function here. So let's first of all get rid of them so they are not, so they're below the limit. I do have a count function somewhere, I think. Of course, I can't. Yeah, current hard framer count. Maybe we can make this a bit more universal. Well, I mean, this is yeah, I need to do includes here and give the pass an array here and change the filter to contain these two. That would be I includes no cell IDs includes I guess, and that is current hard framer count. Yeah, it's the count we need, right? So like let's copy this. Right, and then that should be this array, right? So now we have a universal function that that counts the cells that have this amount, or these cells, right? The amount. So let's see if that still works. That is used for the limit. Yeah, for the limit for the hard framers. So if I do 1 and I put 10, it puts 2. Okay, I have 2, of course. Yeah, I didn't see the second one there. But yeah, that's 5. If I do 50, it goes to 5. So that function still works. And now I can use this current cell count to limit the positioning of mobs, right? Where is this done? That's synonym.on. Yeah, it's this one, construction board, cell clicked. Right, switch cell to insert. So I have some very sanity checks here, right? So if you have low, you have to remove all the other lows, right? If you have the exits, you have to remove all the other exits. And now we have to make sure that if we do skull, we have to make sure we only have 10 at max. So the current skull count is this cell count, and then the function name current cell count of this cell skull. Return so I want to not do anything though, so I guess I want to return. Right, why does it return here? So if this construction board data over mapping, oh right, wait, so I guess I just have to return from this function though, like if skull count greater than 10 or greater or equal than 10, we just don't do anything. Is that sufficient? So clear this level. One, okay, no, that's wrong. Includes is not a function. That's weird. Right, it has to be an array. One, two, three, four, five, six, 7, 8, 9, 10, and nothing. Okay, yeah, and it doesn't affect anything. Perfect. I mean, I could pop up a message here though, like that's something I might add, because I have to do this verification, the maximum amount of enemies per item, and also whether there's a low and an exit in the level. So those are 3 sanity checks I have to do, or like 2 plus for every mob. But yes. So yeah, we just return and don't do any updating or inserting. I think it's the same for snakies. And the same for Medusa we saw. Actually, we can simplify this function because we do know the cell to insert though. Yeah, so let's do this. Right, so right, so Snaky, Medusa, and Skull only have 10 max. Let's see what the other limits are. No, I need you to go to the construction mode. Load state. Do you have a construction mode state? Yes, I do. So we have almas, 5 almas only. Okay, and goals are 10, I think. Yeah, and then regardless of direction, of course, like there's 10 goals. So we have to add goal 2. Yeah, that doesn't really matter. So all the goals, yeah, Snaky, Medusa, and Skull. That's everything, right? We have Medusa, Skulls, Almas, Snakies, and Goal. Yeah, that's okay. That's another thing that's done. So that means we can add 2, 3, 4, 5, and no more. We can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and no more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and no more. Medusas we tried already, right? I think. Yeah, and no more. And the skulls we did. Okay. Yeah, that's this. Right, that's our simplification of the function. Okay. And then before exporting, we need to check. So I can't export this level because Lolo is missing and the exit is missing. And you see the same thing, like the same thing happens in the game itself, right? If you remove either of those and you go, yeah, if you try to escape, if you try to play the thing, then it says error, no Lolo or exit. So we have to do that too. I think I might play with the colors of these round numbers too to make sure that to indicate whether there's an error in the level. But let's first just add that message when you try to export. Actually, I can just show that all the time though, because I have space here to add messages. And I can, if you're clear, I can just immediately show the message that Lolo is missing until you add it and the exit too. So let's add a line here. Well, let's put that in the Chrome. Wait. So let's see. Initialize Chrome, and then we will initialize errors. Right, and then after buttons, we have our error messages. We don't need an error container. I'm just going to put that in the Chrome container, I think. Although I do need. Yeah, I need a reference to the text object though. Did I call it texture? Well, that doesn't really matter. Okay, and then so this error message texture is new, is this create text, which is empty to start with, size 16. Well, no, let's put something in there. so we can see it on screen, and then let's set the position to what was it, 0.19 I think is the clear starts at 0.19, yes, and let's start at 0, that's center. I'm going to set the tint to red, or a red like. I think I have to, let's get the same red as this one. Okay, and then add it to the Chrome container. Okay, let's see where that ends up. Okay, that's all the way at the top. That's strange. Oh yeah, no, I need to do quarter pix, of course. That should put it here. Nope. Did I make, okay, another dot. Right, that's too big. Still too big. Let's put it down a bit. Can I do fractionals? Yes, I can. I think that's the longest error message, because there's a message Lolo missing and exit missing. I don't think I need to do anything other than that. Let's add a line. I could put that in a function too, of course. That would make more sense, of course. At point, why is it so? Oh no, that should be positive 6. Well, 7. Let's put 70. Let's see where that ends up. That's a bit lower than 74. Okay, and I put the text a bit higher. Okay. Of course, if the error isn't shown, then it's just empty space, but that's fine, I guess. We have to have a function to update the error, or check for errors though. Check for errors. And this looks in the current level, in the current round, to see if there is an error, right? So we have Lolo count is this count, cell count. What was the current cell count? What's the function called? Of this cell Lolo. And then exit count is cell exit, or cell exit with framer on top. Okay. If Lolo count equals 0 and exit count equals 0, then we put our error message dot text to error Lolo and exit missing. Else, if Lolo count equals 0, it's just Lolo missing. Else, if the exit count is absent, then it's exit missing. Okay, else there's no message. Okay. Now we just have to call this function every time we do something, and that would be loading the level and clicking the level, right? So actually we do this in the constructor after, so we select round number 1, and then we immediately check for errors, which there won't be because I'm loading level 1, right? Now, it does look a bit silly with this being empty, but I mean, it is what it is. And then we will see where our click thing was. This function here, every time we click, we check. So we do return here, but that doesn't matter, right? We have to update and then check for errors. And that should do the trick. Because now if I take the walkable thing, the walkable space, and error is Lolo is missing, and Lolo and exit are missing. And if I put them back, yeah, so that's good. I have to prevent the export from functioning though. So I have to let this one return a value, a bool to indicate that it's fine or not fine. I guess true means no errors. Right. I guess we can put that out on the function here. So now this one actually indicates or tells us whether there are errors in the level or not. So in our export, this is the encode function. This has to return if we have errors. So if not this error, nope. What is the function? Check for errors. That's a bit stupid though, if not check for errors, but sure. So if that's false, we return and we do not do a thing. So if we remove our Lolo here and we export, we don't do a thing. I mean, I could put an right. No, I need to check all of the levels. Crap. That means I have to cycle through all of them though. Yeah, because like I can do this and then it does export. Well, oh, no, I need to do a check for errors call in that function to, it's this one here, select current round number, needs to check for errors as well, right? Because that has to go away if I have an error here. And I go to level 2, that doesn't have an error, so that has to. Okay, so let's look at the function again, and we can perhaps give a. Does JavaScript have default values? Default parameters just equals? Yes, same as in C++. Okay, sure. We can do round number equals null here, and then our current cell count needs to do that in the right. We have to do it here as well. Round number equals null, and then if round number equals null, we do this. Else we do this, right? So that should still work without that thing specified over here. And then check for errors can also pass this round number to this function, and then we get the Lolo count and the exit count for that, for either for the current round or for the one we specify. And in our encoding function, we can loop all 5 of them. So let's do that. Again, with the one-based stuff, I have to fix still. Do we start on false or true? Let's see if this. So if we don't have errors for round number, wait, why do I need to do this? Oh, no, I need to do this differently. This needs to be I, so I'm not overwriting that value. Wait, so where am I using round number? Yeah, no, this doesn't need to be passed, right? Because I'm doing all 5 levels anyway. So where am I calling this? Yeah, no, this doesn't need to be the case, right? So, and I can indeed use round number then. So if this has errors, error encountered is true, and we can break because we don't need to check the other levels. And then if error encountered, we can what's the correct way to say this? An error has been found on one of the levels. I mean, I guess I can. It would be on round number, right? Because we break. Is this scope correct? Is this scoped outside of the? I don't think it is, right? But that doesn't really matter. So we alert, and then we at least indicate which round has an error. So we introduce an error here. We go back to round 1, export. An error is present on round 3. Not the best. Oh, that's not good. Wait, how did that happen? So we go back to 1. We do export. Error is present. Okay. So we return here, and then it doesn't update errors. Who calls update errors? What's the function called again? Check for, was it check for errors? Oh, right. It's crap. I mean, okay, so this is a separate function that just checks whether there is an error present. Return Lolo count equals 0 or exit count equals 0, and then I mean I have to do the same thing here though, like because otherwise I mean I'm combining these two into one return value, right? So I can't use it here. Let's call this update error message, and then we're using is error present in this one. So if this is error present, yeah, okay. So round 3, introduce error. That works. Still with this one too. Okay. Go back to level 1. Export. An error is present on round 3. Okay. What we can do though is jump to level 3 to make sure that to help the user. So an error is present on round 3, and then we say disk current. No, I think I have a function for that. Select current round number. And then that would be a round number, right? So we jump to the correct round number at least. So we don't have Lolo here. We export round 4 and we jump to round 4. Yeah, okay. A bit of error checking. Okay, that still works. I think that's about it. Did I include the amount checks? Or was that previous? Yeah, that was the previous commit, right? Yeah. So add error checking before exporting. Show error message in UI. Okay. All right. So I think we're pretty much feature complete here. I mean, I can spruce this window up a bit, this dialog, this pop-up, because it's not looking super great. But yeah, I think that's about it. I mean, I can't flip Lolo still. I guess I can do that because in the game, Lolo is flipped here for some reason. It's always on facing to the right. And the standard texture is facing left. So, I mean, this is a minor detail, of course. But if we go look at where the Atlas data is fetched, where is this initialized textures? Yeah, no, I can't easily do that. I have to flip it in the texture then, I guess, but that's not really important. Right, so all we have to do is add some text, I guess, underneath this to explain how it works. Also, what I wanted to look at is to export an entire disk file, which means I have to like format a floppy in as a file, of course, and then put the puzzle file onto the disk. Because now you have to use the disk manager, right? But that's not a huge deal. But you have to like use the disk manager here to put the puzzle files onto the disk. Of course, you have to load the disk anyway, though. But why is this empty? Oh, are we back in VG8020 or? Oh yeah, back in the standard one without the disk image. Also, I have to look at putting perhaps a CRT shader on top of it to make it look a bit better, old style. I mean, I have looked at these at this one to put on top without curvature. So without this. But yeah, we can add some scan lines on it. I have to look how that works, because I haven't done shaders with Pixie yet, so I have to look into that. Yeah, I think that's it. That's about. Oh yeah, no, I have to do the resizing, right? That hasn't been done yet. So when I resize the window, it has to resize everything in the UI as well. I have to do that as well, right? Yeah, let's add some instructions, I guess, underneath. Let's see. I'm gonna put that at the bottom, then the container, and then we have an H2 instructions. I have to give that a style. Font size a little bit smaller. Margin top is fine. No border. Okay. Let's see. What do we need to explain? We need to explain the limitations and how to import it, I guess. Okay, so just like the construction. Oh, look at that stupid, these artifacts. That's from scaling. That sucks. Sometimes there's artifacts when you scale down or scale up, when you're at a wrong value, like an odd or even thing. That sucks a bit. I don't know how to fix that, but sure. No, so okay, just mess it up completely then, sure. I mean, that's my fault though. I did put it on 200 here. That's fine. And then you pick a specific tool from the tool palette and click on the canvas on the left, to place an instance of that tool, of that item, I guess. Do I need to explain anything about this? I mean, this is, it does say exit underneath Emerald Framer. It does have an explanation of all the things though. Clear the level immediately by pressing the clear button in the bottom right corner. Okay. Oh, right, this bullshit. Right, so now the power-ups, you can add 3 power-ups to each level. Click the box to cycle through them. Also specify the amount of hard framers that need to be picked up before the power-up becomes available to the player. Right, that's this. Of course, the maximum is 63, but it is also limited by the amount of hard framers in the level, in the round. I always call it level, but it should be rounds though. They consistently call it round, so, well, semi-consistently. Like for bonus levels, it's bonus stage, and for the rest, it's always round. So you can add 3 power-ups to each round. Click the box to cycle through them. Also specify the amount of hard framers that need to be picked up before the power-up becomes available to the player. The maximum is 63, but it's also limited by the amount of hard framers currently in the round. Okay. So the import now only has the built-in levels, but I do plan to have it import player-made levels, like put them in a database and stuff, and just load them up by ID or whatever. Like, but I don't have that database yet. Oh, I do need to add some dirty check though. Yeah, because if you import, like for clear, I do ask whether it's okay, but for import, I don't. That I have to add. I mean, it is important to not overwrite your stuff. I mean, you do have to explicitly click on a number here for it to import, but yeah, I don't know. So we have power-ups, and then, okay, import, we can do 2. Okay, so this is not a bug, right? So the bonus stage 3 and 13 are the exact same. That's their choice. I guess they ran out of memory or time or whatever to create levels. How do I set up a local SSL cert? You mean for my test thing here? Actually, I get because I have a wildcard SSL certificate which I use for my local testing, and I just ask what is it called, certbot, the thing. What is it called? from the Let's Encrypt. I get a Let's Encrypt certificate, a wildcard certificate, and I just use that so I can reference all of them. That's the easiest for local development in my mind. But yeah, and then you just configure Apache, which is what I use here, and then you have your local certificates. Of course, mine now has expired, but I mean, you can just ignore. If I'm working locally, it doesn't really matter. But yeah, this is running locally on this machine, right? So it's just simply a Let's Encrypt certificate I download and put on the machine here. Nothing special. Export the level by clicking on the export button. You will receive a PZL file. I don't think I put the name in. What did I do? Tests? Yeah, let's not use tests.pzl. Let's use 1, 2, 3, 4, 5, 6, 7, 8. That's too long. You will receive an which you then have to add to a disk image. You can use the Open MSX disk manipulator, I think it's called. Yeah, disk manipulator. No worries. You can use Open MSX disk manipulator to transfer the PZL file to a disk image, which you can then load in the game's construction mode. Okay. And I think that's about it, right? What am I missing? Maybe I can add the limit thing. Can add 3 power-ups. There's a limit of 10 instances of Snaky, Skull, Medusa, and Goal, and a limit of 5 instances of Alma per level. That's hard-coded. That's a hard-coded limit. Yeah, that's about it. Yeah, I just have to do the resizing then. That sucks though, because that's not going to be fun. Okay, so let's read this quickly. Just like the construction mode in Eggerland Mystery, you can design your own rounds. There are 5 rounds. You can export load at the same time. Click on the numbers 1 to 5 at the top right to select the round you want to edit. Pick a specific tool from the tool palette and click on the canvas on the left to place an insert of that item. You can clear the level immediately by pressing the clear button in the bottom right corner. You can add 3 power-ups to each round. Click the box to cycle through them. Let's move this up. So there's a limit of 10 instances of Snaky, Skull, Medusa, and Goal, and a limit of 5 instances of Alma per level. You can have 3 power-ups. Click the box to cycle through them. Also specify the amount of hard frames that need to be picked up before the power-up becomes available to the player. maximum 63, but is also limited by the amount of hard framers currently in the round. You can import rounds that are in the original game by clicking on the import button and picking the level. Note that there are 20 bonus stages, but the first 10 are duplicated. Export level by clicking on the export button. You will receive egger.pzl file, which you then have to add to a disk image. You can use the Open MSX disk manipulator to transfer the PZL file to a disk image, which you can download in the game's construction mode. I mean, that's it, right? That should be all the information you need. I mean, it's pretty straightforward. Let's commit that. Add instructions. And then the resizing. I've rather doing the resizing because I don't like that. That's going to suck. I do have a resize observer, I think. Yeah. So can I just call the render functions again? So like the initialize Chrome function recreates the containers though. I guess that works. I mean, I know I have to remove them from the stage, right? That's not really good because I don't really want to. I mean, I could remove the Chrome container from the game, but then every time you resize the window, it's like recreating all these containers again. I mean, I guess I can debounce it a bit by just waiting a bit whilst doing that. Let's try that. So this app stage remove child, this Chrome container, and then initialize Chrome container. Where are you? Initialize Chrome. So let's see if that does the trick. I mean, if this is like what? Oh, does this get called immediately? Yeah, it does. It does. So it doesn't yet exist, I guess. So that means we have to do that at the end. But we're still doing it, I think. So yeah, I think this gets executed immediately, which is not really good. Yeah, of course it does. Okay, that looks great. So does that mean that we can remove this here and put this in its place? Why are you so big suddenly? This power up data, this current round number. Okay, so I don't want to do this for the first time then. Only when there's actually some. Okay. So how do I do this? I guess I can do it stupidly by going like this. First render equals true, and then put this here to false. Okay, so that prevents that at least, but why is it so off in the sizes though? That's weird. What did I do wrong now? Oh, am I writing something? New width, new height? Okay, I do need to do the resize first, I guess. Okay, sure. So we have to do this at the top then. Sure, sure. And no, so we have to do this specifically after, right. So we're not doing this initially, but only when resized. So does this work now? Yes, it does. Well, of course, not everything, right? I'm not only looking at the chrome, which is the outer, like the brick wall, which is resized, and I think the round things are also part of the chrome, and the lines here, yeah. So that does seem to do the trick. I mean, it's not efficient, but like who's gonna scale their window that much? So I guess we can do this one too, and it's basically down to this, right? I put everything in containers. Yeah, so I can just do the same thing with this. And then call initialize construction board. Does this work? No, it doesn't. Why are you messed up? It's this one. Oh yeah, of course. Yeah, it clears it. That's not good. I'm going to have to separate these out. So let's make that a different function and make this initialize construction board and call this render. Actually, I'm going to do this, and then I can refactor this name, render construction board, and then initialize is something I have to do once at the top. Right, that's just setting memory, right? And it's not needing anything specific, just the width and a walkable space, okay? And then we can render it again. Okay. Why are you not rendering? Oh, do I need to clear these guys? I guess I do. Well, no, it's a new array though. It's override. It should throw that out. Why would that not work though? Is there something wrong with the okay, no, with the height calculations or something? So 18. I mean, yeah, they're scaling up. That's correct. What's wrong here? Like we're creating new sprites. Yeah, that should be fine though. Oh, do we need to call an update? Oh, right. We need to call an update, I think. Right. Because we are doing the same thing here. Actually, we don't. But I think we should update construction board. Yeah, let's see. Do we need to update first and then render? We might. Yeah, we need to update. So what does update do again? It sets the textures. Okay. Oh, right, because these have invalidated, right? These sprites are not valid anymore. Right, that does make sense. So that works too now. Right, that's good. And now the tool thing, where is that? I thought these were in Chrome though. Oh, right, we're duplicating many times here because we're not removing them, right? Because the initialize Chrome calls the tool rendering and stuff. So it's the walls and also these guys, right? So round selection is part of Chrome, I guess. Yeah, this gets put into the Chrome container, but these guys not. So initialize tools, yeah, so this one has to be removed. Right, that will prevent that duplication. Yeah, and now the power-ups and the buttons. I don't know if we're missing one now. Doesn't look like it. Like highly inefficient because we're like creating, removing all the time. But yeah, that's fine, I guess. At least the resizing works now. I think I have to put minimums and maximums on it. I mean, it's up to you, I guess, how small you want to make it, but it still works, right? So, I mean, it doesn't really matter. Like the text is going to get, oh, that's not scaled. Okay. I thought that was going to be scaled. Also, the order, oh crap, the order is wrong too. Oh no, do I just have to remove it and recreate it again? I think I do, right. It's initialized import pop-up. Yeah. I just have to do the same thing with this one. And then yeah, that might scale it again. Let's see. Yeah, I mean, that gets quite small. Oh, does that goes away? But is it still, it's not still active. Okay, fine, that I can live with that. Yeah, I don't think I need to limit it though. Like you can do it full screen, I guess, and get, oh, look at that, all this garbage. Look at that shit. Like why? I guess I didn't put margins or paddings in my fonts. That's why. Also, there's lines. Like I don't know if you can see that, but there's like empty lines here, like 1 pixel lines. Don't know how to fix that. Yeah, I think I need to add padding to my font here. Because that's not good. I needed to do that. I had to do that for the tools as well. But yeah, at least the resizing works. So that's done too. Right. And then let's see. Yeah, that font, is it reproducible? Yeah, it looks like it's always there when when the font is big. I mean, if you look at the font, they're touching, right? So, oops. I mean, there is one pixel padding though. Although no, I give them 8x8, and they are 8x8 next to each other. So That's probably why. That sucks though, because that means I have to change my XML file too. I guess I'm gonna have to do that. There's not much I can do about that. But yeah, that's not for today. Yeah, look at all these stupid 1 pixel lines. For some stupid reason, it depends on the size, but why is my round not selected here? Does that go away? Yeah. Okay. Crap. Is it this function that needs to be called? Yeah, I think it is. So we need to select the current round number with the current round number as the parameter. Yeah. Okay. Okay. That's going to be it, I think. Yeah. Yeah, I don't have anything to do now, so I just have to finish this a bit, like spruce it up a bit, and then I'll put it online so people can try it. Okay, but that's going to be it for the stream. Thank you all for watching, and I will hopefully see you next time. Bye bye.